Hello, everybody. Thanks for having me at your conference. I should point out that I have been talking to the organizers of Mobius for many years now. They're very persistent in trying to get me and some of my colleagues to come present in St. Petersburg as well as Moscow at the Mobius conference, and it never worked out until I didn't have to travel to get there. So it's great. It's unfortunate that this is not in person. I would prefer to be there in person, but it's great that we have the opportunity to be online and participate in the conference anyway. So thanks for having me. Thanks for organizing and thanks for hosting. I have been to St. Petersburg many times in the past. I used to work for Sun Microsystems before that company went away, and they had an office in St. Petersburg, and I really enjoyed going to visit the city. I prefer to visit it in person, but it's nice to be back there virtually anyway. So why don't we get started? So I was asked to talk about modern Android development. I should point out this is the first time I'm actually giving this talk called Modern Android Development. But in fact, we have been talking about modern Android development and using the phrase modern Android development for years. And so the purpose of this talk is really to explain what we mean by this and make it a bit more concrete. So for example, Romain Guy and I talked about modern Android development back at Android Makers, a conference in 2018. We described modern Android development then. And then a couple weeks after that at Devoxx France, we also talked about modern Android development. And then after that, in May of 2018, we gave a talk on the big stage at Google I/O. Again, modern Android development. Then at the Android Developer Summit the next year, we talked about modern Android development. And in fact, I think we gave the talk, a version of the talk again at a small conference in Greece just last year. But the premise of that talk was slightly different than the premise of this talk. That talk was basically saying, here are some practices that we used to advise developers, and here are how the practices have changed over years as the capabilities of the devices, capabilities of the platform, the capabilities of the development community have evolved over the years. And so it was really sort of a comparison of the old and new, but not in any concrete way. The way that we use modern Android development, the phrase now refers to a specific set of features, capabilities, tools, language, APIs that are, for the most part, optional to use, but that we really recommend that developers use to get the best experience and the easiest experience for developing for Android across the broad ecosystem that we have. So first, I want to talk a little bit about classic Android developments. So what did things used to be like? First of all, let's take a look at a little bit of history. So if we look at the first release that came out, the initial SDK release in late 2007, it was called the M3 release. It was a Milestone 3, which came after Milestones 1 and 2, but those were internal. And these had all of the fundamentals that are still in the platform. It's kind of amazing to look back at that ancient release. This is pre 1.0 and see how much was actually in the platform and how much developers could already do with the platform to write applications. So for example, it used the Java programming language, which obviously we still offer for all of our APIs and developers. Tons and tons of platform APIs, obviously not as many as we have today, but a lot of the basic capabilities, the view hierarchy, activities, all of the framework stuff, download manager, like all this stuff was basically there. We used Eclipse at that time, specifically the Android Development Toolkit, ADT. Can't remember what it stands for. The ADT plugin for Eclipse, and that was the tool chain, that was the IDE, and also a bunch of other tools that we bundled with it. And we also used and still use APKs for distributing applications. So you would bundle everything up. You basically zip it or jar it up into this file that contained all your executable code as well as your assets and resources, and then upload that to the Play Store. And then your users could download that APK. After that, about a year later in late 2008, 1.0 came out sometime around September. The G1 device launched, and then everything followed from there. For years, then we had the addition of more platform APIs. Let's add more capability. We're basically playing catch up to where we needed to be, right? So 1.0 came out and had a lot of important capabilities for a smartphone, but it didn't really have enough. Right? People had higher expectations, especially when you're covering a market. You need to cover things like, better handling of density for random configurations from random manufacturers and random devices that are coming out. You need better internationalization support, BiDi support for all of the languages that are out there, and just, more performance, more polish. And so we just kept adding more and more platform APIs along the way. Eventually in 2013, Android Studio came out, which was a pretty huge change for us because we were kind of stuck in a corner with the Eclipse IDE, and Android Studio really took us to the next level with tooling support for Android. Kotlin Support came out in 2017. Turns out a lot of people were using it already, but then we actually started officially supporting it in the tool, which meant that we stopped breaking people who happened to be using it at the time. Architecture components is kind of a key element. So we already had a lot of things coming out in support library like Recycler View and AppCompat and various utility libraries, but architecture components was really the first step toward modern Android development for the APIs. It was this collection of optional components that you could use, optional libraries that really made your lives with Android development much, much easier than they were before. And then app bundles came out more recently from the Play Store, which enable a better distribution model than the original and long-lived APK distribution model that we talked about before. All right, so if you're talking about the language, okay, so we've always supported the Java programming language, which is great. There's a huge developer base. So these are some of the reasons why the language was chosen, why it was a really good choice, and why it's worked well for people over the years. A lot of developers already knew it. You tend to learn Java at the university level or even before, or people were programming on the back end, on servers, doing web stuff, doing database stuff, whatever it is. A lot of people knew Java. So then picking up the Android platform meant learning the new APIs and the new ways of building mobile development applications in a very constrained environment, but at least they didn't have to worry about learning a new language along the way. There were a lot of tools out there, including Eclipse, and these tools tended to be free, just given the way that community works. Tons of existing libraries and approaches that people had. They already knew how to use Java, and they knew different ways of using it, different patterns, different libraries that they could use for middleware to make their lives easier so they didn't have to write all of their applications from scratch all of the time. The memory management, obviously for Java or any higher level language, it handles all that allocation and deallocation or garbage collection stuff for you compared to C++. At the time, we were actually debating on the team which language or set of languages to support. And in fact, one of the original ideas was maybe we support all of JavaScript and Java and C++. And Java came out ahead for various reasons. And one of them was simplifying development efforts so that all the developers didn't need to worry about memory management. Now, of course, we have native support through the NDK now. So the developers that choose that can do that, but they don't need to if they don't have to. On the tools side, so as I said earlier, we had Eclipse with the ADT plugin. It was free. That was great. It was familiar development experience. So if you had been developing with Java before, chances are you probably were using Eclipse because that was early on kind of the standard that everybody used, not just for native development, which I believe it's still sort of standard now, but also for Java development. So developers knew this, and again, it made it easier to enter into the Android ecosystem. I should point out that it was free. It was possible, not easy necessarily, but it was possible to integrate other tools. So not only did you have the ability to have this editor where you could type your code, but you could have other tools like the trace tool that we had for profiling and some other tools. DDMS ran in some sort of Eclipse environment. So you had some sort of integration of the various tools that we offered. Not great, but it was there. And also, finally, I should point out that it was free. On the API side for the libraries, what we offered in classic Android was basically APIs in the platform. We released platform versions frequently, really frequently in the beginning. I'll show a little history here in a minute. There was new functionality in every release, sometimes really fundamental functionality like internationalization support, sometimes a little more nuanced, like we made things perform better and act smoother and things were a little more polished, but really pretty huge changes in every release going forward, tons and tons of bug fixes. So you really kind of wanted to keep up with the latest releases. As long as your users had them, right? That's the key. So if we take a look at history, 1.0, as I said, came out in late 2008, and then check out these other releases that came out. I mean, sometimes for the first 2 to 3 years, the team was working on anywhere from 2 to 4 releases in parallel, all at the same time. Sometimes the releases were coming out within weeks of each other. And these were huge releases with big changes, right? And then developers would need to consume, and then manufacturers with their new devices would also need to support these things. And so it was kind of a race as the entire ecosystem played catch up to where Android needed to be. And then finally, things got a little bit more mature and we spaced things out and went to sort of an annual release model for the last several releases. And we're pretty much sticking to that cadence. It's a little easier for our partners, for manufacturers to absorb these releases and make sure that they're supported on their devices. And it's a little easier for developers to sort of understand what's going on with the new release like Android 11, which just came out in beta recently. And then also previously, we had the distribution model, which, as I said before, was APKs, and you basically zip the stuff up, uploaded it to the Play Store, and then it got downloaded onto all the devices. But what if all of those devices had different configurations, different screen sizes, different language support, locale necessity? So you could either, you could do one of two things. You could have more APKs that then you just manage, right? So you figure out all the configurations that are necessary and you make specialized APKs for each one of those situations and then manage that mess on your side as well as on the Play Store side and upload all of them. Or you have a monolithic APK and just upload this huge thing that now all of your users need to consume. So it basically creates a really large release when the users don't need all of that stuff, right? They are not going to need support for that particular locale, but they got it anyway because you just have a monolithic APK up there. All right, so some of the problems, I talked about some of these along the way, but some of the problems that we had, so with the Java programming language, it's still a good language. Let's be clear. It's great. Its support across the ecosystem and the developer community is fantastic, but it is verbose, right? So languages have the same issue that APIs, that libraries do, which is you can't just change it, right? You can't just say, well, we're tired of that keyword, so we're going to remove it. No, you're going to break applications if you do that, right? So you add capabilities to it, but you add it slowly and incrementally because you don't want to freak out this massive development community that you have. Which means that all of that verbosity that was in the original language that we didn't really used to think about because there weren't really a lot of options at that time is still in the language, right? So you end up writing a lot of boilerplate code for situations in the Java programming language that are much more concise in other more modern languages. On the tool side, we had Eclipse and ADT, and it was fine, but it was difficult for the team to customize, right? So we could add some tools in there, but there were really some very hard edges. I remember filing bugs and talking to the team occasionally about the way things worked, and wouldn't it be nice if you could? And their answer typically was, yeah, but we can't, right? The framework is what it is. We don't really have the ability to change the underlying framework, and there's only so much configurability that we have. So we were really sort of painted into a corner with Eclipse and with ADT at that time. So then we ended up having a bunch of subtools that either, some of them ran within the IDE or ran within, this other version of the Eclipse framework, but they sort of had inconsistent UIs. They worked differently. They didn't really fit together into an integrated solution, which certainly makes it easier for developers as well as for us, but mostly for developers writing applications. The core IDE, like Eclipse, was really powerful and great to use at the beginning because it was so full-featured at the time compared to everything else that was out there, certainly for free tools, which was a requirement for us at the time. I'm getting a message from the team. I cannot pay attention to that right now. All right. Completely lost my train of thought. Okay, so, but the problem was once Eclipse achieved a certain level of usability throughout the ecosystem, they kind of stopped improving it, right? Some of the core companies that were contributing at a fundamental level went off to do other things because, maybe not everybody wants to work on a free tool. What is the benefit to doing that? So they sort of got it to a really good level of functionality, but it didn't really advance after that. And in the meantime, Android is building its entire ecosystem on this tool. And so there was kind of a requirement that we work with a tool that could grow with us, that there was still active development happening in. And we didn't really control this, right? It was an open source project, or is an open source project, but we did not control that, right? We weren't driving this thing. So even though we were probably one of the largest users or had one of the largest use cases for it, there really wasn't much that we could do about our future in using this tool. On the API side, some of the problems that we ran into were, okay, so as I said, we were developing all these APIs for the platform. But this means that you as developers, in order to take on these new features, these new capabilities that were really important, or new bug fixes that were also really important, you had to know that your users were getting those releases. And they would eventually. Certainly in the early days, as they were coming out really frequently, maybe they would get it sooner. But as the ecosystem got more mature, as each release got basically more robust and solid, there was less incentive for manufacturers, for partners to necessarily upgrade to the latest release on a really timely scale, which meant that you couldn't depend on your users getting these new features, getting these bug fixes quickly. So then what, as developers, were you supposed to do except wait? Right. So you implement this functionality and you hope that your users will get there eventually. And so it was difficult for you to take on these new capabilities. And it was difficult for us as the platform team to get developers excited about using these new capabilities, because the answer started to be, well, why should I care if my users won't have this capability for the next 3 years? Right? I will talk to you. I will look at this API in 3 years, because that's when I will have users that may care about it. So it was a little harder for us to sort of advance the capabilities of the platform in the ecosystem, because we couldn't really get developers to adopt things that users were not going to get immediately. Also, the platform, frankly, was complicated. Writing mobile applications, doing the things that you can do on these really constrained devices, is difficult, right? You have limited memory, but you need to run multiple applications, which means some of them are running in the background, but there's an activity manager running in the background, making sure that, well, if you run out of memory, we got to start killing stuff. Well, if you kill stuff, then your application needs to know how to handle these lifecycle events, needs to know how to handle the situation of getting automatically killed in the background and then relaunch to go into the foreground, bringing in its save state, making sure you're not leaking memory when windows go away. And frankly, things were complicated. APIs were complicated. Use cases were complicated, especially because not only are all these things inherently complicated, but in the early days, things were so incredibly constrained that our APIs tended to be very specific to situations that did not require allocating and collecting objects, because it was incredibly expensive. So even though we had Java developers coming into the Android development community, knowing the language, the patterns and the practices that they needed to use for developing Android applications were a little bit different. Way back in the old days, we used to recommend against things like enums, because that allocates memory for reasons that are not necessarily, like, if there's a better way to work around it. This became a big argument in the community in general, but just in general, if you look through a lot of the core older APIs, we tended to pass around primitive objects. We would never return, let's say, a rect object. Instead, we might ask you to pass in that rect object and we would fill it in, and that allowed you to retain that object. So we didn't have to allocate one every time you asked us for the size of that object or whatever. Simple example, but basically you see primitive types all over the place, which Java developers had kind of moved away from in their practices, but then needed to move back into in Android development. So in various ways, the APIs and the platform development was complicated and difficult for people to understand all of, and to write applications that really handled it all correctly. right? Things like lifecycle, as I said, understanding when your application goes in the background or gets killed or gets started, gets paused and resumed, like all of this stuff, super complicated to understand. Storage, where do I put these things? What permissions do I have? Navigating, especially if you're going between different activities, or the more modern approach of having a single activity and going between fragments. All this stuff is complicated in terms of both architecture as well as simply the APIs that we had created early on. And again, let me return to this point. If you create an API, you cannot delete it, right? So even if we come up with a better approach of doing things in the platform, we can't get rid of the old stuff because we're going to break applications, right? So all of the old complicated stuff is there, even if we come out with something better and more elegant in the future. And then finally, on the distribution side, previously we had these APKs, and they tended to be huge. They would handle all the situations that were necessary for users, even though any particular user didn't need all of those assets, right? They may only have one language that needs support in the system, but your monolithic APK would have support all of the languages that were possible for your application. Or you just ship all these APKs and then you manage it on your side, and it's kind of a mess. So our answer increasingly is what we call, obviously, modern Android development, which I just went to the website yesterday. We have a landing page that describes some of what I'm talking about there. I'll go ahead and read it. Development tools, APIs, language, and distribution technologies recommended by the Android team to help developers be productive and to create better apps that run across billions of devices. So these are optional pieces for the most part, right? Optional language, optional APIs, but we recommend that you use them because they're going to give you a better development experience. They're going to make it easier for you to write rich applications that run across many devices. And that last part is key because we're talking about unbundled libraries as opposed to the platform APIs that we all know and love from Android development over the years. All right, so here's what it looks like. I think of it as the pillars of modern Android development. So I drew this very ugly diagram to illustrate this. So at the bottom, this is the part like everybody's got the foundation. You're not going to, get rid of the foundation. There are some core APIs in the platform that everybody's going to use. We're not taking them away, and we're also not substituting them with other things and unbundled libraries across the board. Instead, we're solving specific use cases where an unbundled approach would be better. But anyway, you've got this foundation layer with the basic capabilities of the platform APIs, as well as Play distribution and the Play console and all the capabilities that they have up there. You can check your vitals and your app, all that stuff, right? But then on top of that, we have the modern Android development pillars, which I think of as the language, the tools, the APIs, and the distribution model. So I'm going to walk through each of these pillars along the way and sort of describe why and give you some examples of what are in these pillars. So on the language side, the recommendation is to use Kotlin. We know that everybody uses, many developers still use Java, and there's certainly a lot of existing code. Even if you are starting to use Kotlin, there's still a lot of existing code that uses Java, and that's great. But as you develop new applications or as you see the benefit of Kotlin, we would recommend that you move to Kotlin for various reasons that I'll go into. So if we look at historically the development of Kotlin over time, so 1.0 of the language came out back in 2016. And then in 2017, we said, okay, now we will officially support it. As I said earlier, a lot of developers were already using it because the language is really great. But we tended to break them with each release of the tool. And that meant that they would need to, recode, download the new Gradle plugin, change some stuff. Like we would just break them because we were not really paying attention to it at the time. That was not where our focus was. And then finally, in 2017, we said, okay, it's an officially supported language. And then the tools team goes out of their way, not only to support developers that are using Kotlin and to not break them with every release, but they actually use it internally for a lot of the development of the Android Studio plugin itself and other related tools. And then in 2019, we went Kotlin first, which is basically where we're at now, saying, you know what, if you got a new project out there, we would recommend that you use Kotlin for many reasons. And here we are now in the mid-2020. So the question is, what can you do with Kotlin for your project? So there are a few reasons that we chose Kotlin. The expressiveness of the language, there's a lot less boilerplate. So I talked about this with Java, just the necessity of writing a whole lot of code for things that are essentially very easy, and there are more concise ways to get those tasks accomplished now. Safety at runtime is really important, and that comes from language capabilities that allow you to catch the errors and the problems at build time instead. So things like adding automatic null checks that can be caught at build time, like type safety that says, this type can be null or cannot be null, and then we can check at compile time whether your code is obeying that contract and make sure that you break at build time if it's not, so that you're not going to crash at runtime instead. Interoperability was key. The ability for you to go from Java programming language code into Kotlin and back is really important. We didn't just want to adopt another whole language and have an entire parallel ecosystem, because that is a lot of work. Instead, we needed a language ecosystem that would interoperate really well with the existing one so that you don't have to change your code. You can continue doing what you're doing, and you can migrate piece by piece, right? You don't have to start an entirely new project. I was saying, like, if you are starting a new project, you might consider doing it in Kotlin, because that's kind of a nice breaking point. But if you want to add class by class or file by file with Kotlin, you can do that, right? Because it basically sits on top of the same bytecode. It compiles down to the Java programming language bytecode, or in this case, it compiles down to DEX code. So it interoperates really well with the language that everyone's been using this whole time. So this is one of the key elements. We never thought about just changing the language entirely and picking up something unrelated. But when Kotlin came along, we said, yes, that is the one for us. And then structured concurrency is new capabilities in the language in the last couple of years that allow you to do really difficult things with asynchronous programming in a much more intuitive and powerful way. And it avoids what I think of as that sort of spaghetti that you get with these callbacks. All this asynchronous stuff, especially in the mobile space, you're constantly making asynchronous calls. I need to do something. It's going to query a server out there, and then eventually it'll come back and give me some information about there, or I need to send something to the system server, and eventually it'll come back. And in the meantime, you have all this asynchronous state floating around your application. It's really difficult to manage. And coroutines and the new flow capability make that a lot easier. So let's take a little bit. Let's take a look at a little bit of code to walk through some of these concepts. So, for example, nullability, the ability to have types that actually embed the nullability and information in there. So this says this bundle object can be null. So if somebody calls it with a null object or a potentially null object, that is okay. And that gets checked at build time. We have lambdas, concept of lambdas, make things like really concise. Now you can just sort of embed this little bit of code in there instead of creating this whole object, this runnable thing to pass around or whatever. We have extension functions. My personal favorite feature in the language, because it allows you the capability to add and improve API without breaking compatibility. So if you see, we'll see an example of this later, but if you see that there's a much more concise way to achieve some capability, some utility method that you could add, utility function, well, in other languages, you'd probably just add some util class, right? Well, this way you can actually embed it sort of semantically in the class itself. You can say, you know what, I want, let's say, a function that does capitalization on strings. I can add that as a function on string. It won't be embedded in the string object itself, but for the purposes of the code that you write against it, it looks like it's in the string class, which is the logical place for it to be. Template expressions allow you to actually use code itself inside of strings, so you can do really complex formatting of string output, which is really tricky to do in the Java programming language, but you can actually do that in a way that is concise and it's easy to read, and it's actually going to go through the compiler, so it's going to get evaluated at build time, so you know that you're doing the right thing there. And then finally, properties. So it gets around this thing that we've been dealing with as developers for years, where you could expose public fields, but what you really want is public getters and setters and private fields. And this goes away from that notion entirely and just says, no, we just have properties. You can access them as fields, but in fact, you are calling into getters and setters. And then you can do the right thing to spec those getters and setters in the code. All right, so other reasons that we chose Kotlin are speed, and I mean this in a couple of ways. One is the speed with which you can write it, because there's so much less code to write because you don't have all that boilerplate, but also the speed of the development of the language, right? It is a new language. They've been adding a relatively new language. They've been adding a lot of capabilities at the time, but they're also they're very fast at adding new capabilities. Coroutines just came in a couple of years ago and then went final a year after that. Flow, building on that to be able to stream these values from coroutines. That came in very quickly. It's now part of the language. They also, with the extension functions, they have the ability to essentially add things that look like they're a part of the language, but just live independently of that. So it's not like they have to keep adding keywords. They can just keep adding fundamental capabilities of the language as they go with all these powerful mechanisms that they have. So the team that is working on Kotlin runs very fast and keeps adding these things to keep improving the language over time. And we also have people working on the compiler with their team to keep working on the capabilities and the speed of the language and compilation as well. There's pretty good adoption for the language so far. As I said, a lot of people were adopting it at a time when maybe it wasn't that wise because we were just going to keep breaking them. But 60% of the professional developers that we talk to use Kotlin. 70% of the top 1,000 apps contain Kotlin code. And there are several initiatives that also make it more powerful on the tooling side. Lots of lint checks make it possible for you to check the correctness of your code as you're writing it. We have a dedicated compiler team that works with the compiler team. At JetBrains, we add things like the R8 optimizations to make sure that we can create the most optimal bytecode from the code that you wrote. We worked on, most recently, the processing speed for annotations turns out to be bottleneck in builds, just all the stuff that annotations need to drag in. So we've been working on optimizations for that. We're also doing annotations of the platform APIs. So we are adding annotations like recently nullable and recently non-null that are essentially hints to Kotlin so that if you are writing Kotlin code calling into these APIs that do not obey that annotation contract, then it will throw a build warning. We also add nullable and non-null annotations, and these actually throw a build error. Right. So when we add a new annotation in the platform API, we'll add it as recently, which means we're going to throw a warning. So we're not going to break your build. But then after that's been there for a while, the next time we're going to upgrade that to a nullable or a non-null annotation. And now you actually get a build failure, which is good because a build failure means you're disobeying the contract, which means that it could have been a runtime failure. And that is way worse than a build failure. We're also working a lot on KTX, which is the extensions library for Kotlin. So we're adding a lot of those powerful extension functions that I talked about earlier. I want to show an extension function example. So let's say you want to create an app copy from a drawable that you happen to have. So you're going to deal with a couple of APIs. One is create bitmap, going to create this with the right size and configuration, and then this drawable API where you can draw into a canvas that you create. And the eventual app code looks something like this. Not a lot, but a few lines of code where you save out the old bounds, you set the new bounds just for this operation, you create the bitmap with the information that you need, and then you create a canvas and then draw into that canvas for that bitmap and then restore the bounds. And then you have this approach, which is drawable KT is a class in the KTX extensions that just says to bitmap. And now all you do is call that. It's essentially doing the same thing internally. So it's kind of syntactic sugar, but it's really nice syntactic sugar. You should note too that there's a default parameter value there, which is another powerful language feature. So I no longer have to pass in the config, which usually is the same thing, right? It's usually ARGB 8888. But I don't have to tell it that because it will just assume that. It'll assume this null value, which then defaults to that other one. We are also working on various Kotlin-specific improvements. Room and Work Manager have coroutine support that make asynchronous programming of those libraries much easier, and they're kind of built around asynchronous notions. Like Room actually needs to access things off the main thread, so you kind of want that capability. Paging 3 is a complete rewrite in Kotlin with coroutine and flow support. Again, for asynchronous stuff, it's constantly paging stuff in from the database, so you really want to handle that asynchronous behavior a lot more elegantly and easily. Jetpack Compose is the new UI toolkit for Android that's currently in development. It's pre-alpha, being written entirely in and for Kotlin. So that's going to give a lot of powerful capabilities, not just for UI, but also for Kotlin development in general. And lots of docs and training and outreach materials to make all this stuff easier to learn and to use, coming out all the time. Lots of things, new videos and articles in what we call the Kotlin vocabulary series, so you can check those out. All right, so that's language. That's one of the pillars. Let's talk about the next one, Android Studio tools. So a little bit in 2013, we announced that the tool was there. In 2016, we announced that the old tool was gone, right? So we kept maintaining Eclipse for a while, but eventually we deprecated that and said, no, you need to move to Android Studio now. That is where the future is. And we also introduced the Constraint Layout Editor, which is one of the powerful tools I would put in the modern Android bucket. In 2017, we introduced Kotlin Support, as I said before. We also added profilers for CPU, memory, and network. These were a lot more powerful, visual, easier to use than the previous profilers that we had. So more capabilities, but also just easier to use in general. In 3.1, we added D8 support. And this is for faster, better default compiler for creating the DEX code. In 3.2, we added more profilers, so now you can get profiling information on battery consumption. We also added systrace. It gives you more of a system view of your application and allows you to add profiling tags to get even more information about how your application is running. We added the navigation editor in 3.3, which is really important. We're asking developers to move to a model of single activity. So it no longer makes sense in the modern mobile world to have these separate windows every time you want to go to a new state of your application, a new screen. Instead, it's a much better user experience to stay in that one window and just page in the new content that you have, going from a detailed view to back to the list view, whatever it is. So this capability has been there for a while using fragments, but fragments aren't the easiest APIs. So we're doing two things. One is we're making improvements to the fragment APIs to make them easier to use, but also we now build in the capability of navigation with a tool bundled in Android Studio that makes it easier to say, this is the entire flow of my application, and then it does the fragment management for you as you traverse down the hierarchy and back up in your application flow. And then view binding was added recently. It's the ability to have a much more terse and performant way of essentially doing find view by ID. We use data binding for the specific use case to just bind these objects directly, and then you can refer to them as objects instead of saying, find the view in the hierarchy every time with a lot of boilerplate code. Motion Editor is a visual tool that came out recently. Motion Layout came out a while ago and is a subclass of Constraint Layout, and it builds in the capabilities. Think of it as transitions on steroids. It builds in the ability to say, my layout is going to start in this state and it's going to end in this state, and now I want this custom animation to go between the two. And we could even scrub that animation as the user scrolls around in the UI. Motion Editor was a tool that was built from the beginning to be a visual approach to using motion layout. But we only released that tool recently, so that is worth checking out. Right, but in the meantime, Android Studio also, because of IntelliJ, has powerful refactoring, an extensible UI, so we can keep adding these future tools like all the profilers that I mentioned there over time. The core of it is being developed by JetBrains, and we're continually adding to the plugin. So there's a lot of people thinking about how to improve this tool constantly. And there's also tight integration between all of these things with Kotlin, new code refactoring and compilation and lint checks, all that support for Kotlin, as well as for powerful Gradle capabilities for your builds, all these lint checks and quick fixes. So make it easy for you to focus on the really hard programming instead of the easy errors that can crop up that we can point out for you. And most importantly, we think of tools as being tightly integrated with the APIs, with the libraries that you're using. So it's not like you think of using these tools separately. No, it's like navigation. Yes, there is a navigation tool that works with the navigation APIs. We intend that. Motion layout, same thing. We intend you to use the APIs as well as the tool as one sort of tightly integrated bundle. Yeah, so there's examples for that across the board for navigation, for the layout stuff, for motion layout I was talking about, for some of the data binding and view binding stuff. Also for Room, you have the ability to visualize your database now live in real time and interact with it in the tool or on the device itself, and you can do visualization back and forth there. On the API side, let's talk about Android Jetpack. In particular, let's talk about part of Android Jetpack. Jetpack is huge. For modern Android development, I want to focus on specific parts of it that are really the sweet spot of where we want developers to think about integrating these things for all applications that you write. So a little history lesson, Constraint Layout came out. I think this is sort of the first of these modern Android APIs that I want to call your attention to. Architecture components came out, simplifying in Android life cycles. And then the next step of architecture components came out in 2018 at Google I/O. So the paging capability for streaming data, for paging data into recycler views, as well as the navigation stuff I've talked about, as well as Work Manager for doing deferrable jobs, which was really tricky, and everybody wrote a lot of code for doing that essentially in the same way in their code. Material design components, we've had material out there since the Lollipop release, but it was really more of a design approach, and we didn't make it obvious how to actually integrate that into your application. And now we have APIs that make that a lot easier. Camera X came out last year, and it went beta recently. This radically simplifies camera development, not just on a particular release, but rather across releases back to Lollipop, back to API 21, and also across the diverse set of devices in the ecosystem. And then motion layout and motion editor, as I talked about before, sort of the last pieces to call out here. So I'll walk through some examples. So constraint layout, the ability to set up this really rich layout. You can think of it as relative layout plus, right? It's all those capabilities and more, the ability to align views with key lines that you set up in your UI to get the automatic sort of margin inset setup that you want for your UI, and to interact with each other, all of the views interacting and laying out with each other on the screen in a much more logical way, without a lot of the that layout had that we have been advising people to not use for years now. Motion layouts, as I said, powerful capability for doing UI animations, and now a visual tool that allows you to script this stuff in a much more human way, right? Like writing the XML code for motion layout was never easy, and it was never intended to be so. Instead, it was intended to be driven by this tool. Life cycle. So here is the diagram that we have still on our documentation. And we kind of expected all Android developers to know every piece of this, because if you didn't, there's a good chance that you could leak information, you could leak memory between activities, or just not handle things at the right time, cause yourself too much work at startup, crash your app because you're cleaning things up at a bad time. So we needed you to understand all of this, and we needed you to override all of these methods in activity, because it was the only place that you could, or the equivalent in Fragment. These were the only places where you could get the state information, right? So this is not the approach that we recommend anymore. Still good to know about lifecycle, but you do not have to program that stuff. Instead, we have a system where you can set an observer. So we now propagate information about the current state of lifecycle, and you can set an observer, and we can send you that state when it changes, and you can listen in on those lifecycle events. You no longer have to override. Instead, you can optionally choose the ones that you would like to know about in arbitrary code. You don't have to override activity to get this information. And you can also query the lifecycle state, which you never could before. So now the design of these applications looks something like this. You have your UI code and you have your data code, and they should be and are very, very separate. So on the data side, you have a view model, and you have these, what we call these live data objects that keep references to the information, to the data, and then you observe back and forth. You say from your activity or fragments or views or anything in the UI, I would like to observe this information, and then later you get callbacks that give you information about those things. Let's see, moving on. The view model generally sits on top of a room database object, or maybe this is a repository if you're talking to the database as well as the network. Maybe it's a more abstract layer sitting on top. And then there's probably a SQLite database or some other database mechanism sitting under that. The DAO looks something like this. Essentially, it is running SQL queries for you underneath, and then you tell it what those queries are. Simple abstraction layer for doing that. I should note that these are suspend functions. So Room builds in coroutine capabilities because you are going to want to do Room database access off the main thread. So it is inherently asynchronous programming, and Room makes it easier for you to do that with these suspend functions. And so we can see how that sits here. You've got this data model. Again, the user interface over there. All these components are built to work together. So view model and live data are lifecycle aware. They know when they need to clean themselves up, when they have access to data, or when they need to get rid of it. This avoids the leaks that were always the problem in doing this complicated Android programming. Room is accessed using these live data objects. So you're not getting the object itself, but you're rather getting a reference to it that you can then query that is lifecycle aware. Apparently my phone is answering a call. Excuse me. I really want this to stop. I really want this to stop. Wow. I love this online streaming thing. Isn't this cool? You would not have had that opportunity if I were presenting
Chet,
there in person.
Was it an activity you planned for before the presentation or not? I'm just curious.
That would be nice. Yes. I do like it when unexpected things happen in a presentation because it tests us. So really, really happy that happened. Wow. Okay. Continuing. Let me continue. Separates data from the UI. Talked about Room using coroutines and flow to keep that access off the UI thread, which is paramount. And I should point out, too, that although we have built this stuff around live data and our own approach to life cycles, we understand that a lot of developers use RxJava. And so a lot of our APIs and libraries are RxJava friendly. Some of them had APIs that are built in specifically for RxJava, but we certainly don't detract from it. If that is the approach that you use, then you can integrate with our libraries pretty easily. All right, navigation component. One of the things that we added recently are templates that make this a lot easier to create. So this is a screenshot from going into Android Studio and saying, I want to create a basic activity. And then this pops up this navigation graph. You have an application that has these two navigation destinations that look like this. So it is a tool, which means there's probably XML underlying this thing. And this is what the XML looks like. There's a fragment for that first state and then a fragment for the second state. And then each of those inside has an action that are these arrows that we see there. So we basically say from the second, we want to go to the first. And from the first, it's possible to go to the second. Those get encoded as actions within these fragments. And then we refer to the actions in our code when we actually want to navigate, right? So the actions set up the arrows, set up the from and the to the source and the destination. And then in the code, we actually set up the triggers that say, okay, based on this thing that just happened, now I want to navigate to this destination like this. So we just call the navigate function. Right. One of the powerful things about navigation is the ability to pass in this arbitrary data between destinations. So it uses bundles, but we have this concept called navargs, the separate module for navigation that makes it a lot easier to create and pass these bundles along to both embed the information in a bundle as well as extract it from the bundle. It makes the single activity pattern that I talked about much easier because it manages the fragments for you, right? So the fragment APIs and robustness have gotten much better over time. And now, especially since fragments is in the unbundled library instead of the platform library. So all the bug fixes are there to use. APIs are improving, but there's still a lot of complexity to fragments just given what they're doing. And navigation simplifies a lot of that for you. Up versus back has always been a difficult pattern for applications to handle consistently. And using navigation basically does that for free. Work Manager, I'm going to start running really quickly because apparently this presentation is taking a while. So this is a way for you to run deferrable work in the background. Everybody was doing this already, but all applications basically did three things. They would try to use Job Scheduler, which was available only on certain later releases. If Job Scheduler wasn't there, then they would, if they were using Play Store libraries, Play Services libraries, then maybe they could use Job Dispatcher. I think Firebase Job Dispatcher, the name changed over time. And if that didn't exist, in some places and devices, you don't have access to that library, then they would probably set up an alarm manager. And so they would do all three of these things and then pick which one to use based on the situation at runtime. Work Manager, you can think of it as essentially doing the same thing, but presenting you one API. So it's a powerful and flexible API for you to use, and you don't have to worry about how it's actually doing its job. It goes all the way back to API level 14 and then picks the appropriate approach given the API level device, the API level on the runtime device. It has support for periodic tasks, things that you want to run occasionally. You can sequence things to actually run one after the other or together. And you can also specify these constraints. So I only want this to happen when it's plugged in, or I don't want this to happen when the battery is low, or I'm on a metered network or not on a metered network. So for example, in this situation, we're going to run several filters on each of several images, and then we're going to compress the result, and then we're going to upload it to the server. The filters can all run in parallel, and we can set that up so that they do. The compression needs to run when all of those are done, and then after the compression is run, we're going to upload it. And for each of these, we can have constraints like don't run these filters when the battery is low. So we can take a look at a little bit of code. So you implement this do work method and then return whether it succeeded or not. Excuse me. You can set up constraints. So this constraint says I can, I'm only going to do this thing when the battery is not low. So maybe this is where we're going to set up the constraint for only running the filters when the battery is not low. And then we can set up the work request saying, okay, here's the constraints that you had. And there was the filter worker where we implemented the do work implementation. And then we can set these things up to run together. So we tell the work manager to run filter 1, 2, and 3 all at the same time, and we enqueue that. Or in the case that we saw in the diagram, what we actually want to do is then run compression, then run the upload. So we're going to run the first 3 in parallel, then we're going to compress, then we're going to upload, and then we enqueue to actually execute that thing. We also have support in a recent version of Work Manager for foreground services in case you want that capability as well. So it just makes it all easier to use. Camera X, library that came out last year and is now in beta, supports much easier programming of the camera back to API 21, consistent across all these devices. Essentially, you can think of using camera APIs as a lot of applications needed to find workarounds for specific devices or specific device classes, just given the capabilities that those had. We embed those workarounds directly in Camera X. So now you can use, just like Work Manager, a single API to get all the capabilities that otherwise you would have to do directly in your own code. There are 3 use cases that we built into the Camera X APIs. We want to make it easy to preview We want to give you a view of what the camera looks like, to analyze images. So you can run, you can do augmented reality stuff, or you can do object detection, whatever it is you choose to do, or you can capture, which is basically take the picture and save the file. So each of these are simplified. So instead of handing all capabilities of all cameras everywhere, we took a use case approach and said, what do developers really want to do most of the time? And we simplified each of those. So here is a simple example for image capture. You create the image capture object with the target resolution. You should note too that we're asking for a particular resolution. Sometimes that's not possible just given the setup of that device. But then Camera X will make the right decision for you, right? So it's not just going to return failure, which the more low-level camera APIs might. But instead, it's going to try this. And if this doesn't work, it'll try something else and it'll return a reasonable result. And then we bind to the life cycle. This is important because then it knows when to open the camera and when to release the camera. And you don't have to handle that complexity in your code. And then we take the picture and away we go. Other advantages to the modern APIs that we're talking about, we have frequent releases. We're releasing Android X versions every 2 weeks. Not everything every 2 weeks, but there are new releases frequently, alpha, beta, RC, as well as stable. We're developing new APIs all the time. Most recently, we introduced HILT for dependency injection, as well as paging 3, the rewrite that I talked about earlier in Kotlin that makes it a lot easier to do this stuff as you stream the data into your recycler view. And then finally, let's talk about distribution. So Android App Bundle was introduced in 2018, and it was introduced because there's a problem of size, right? So many developers, many users out there don't have much size on their device, right? They have less than a gig of free space on their device, which means not everything they want is going to fit. And what we found, the data says that the less space that users have, the more likely they are to uninstall your application, because to install a new one, well, something's got to go, right? And really, we'd like them to just retain your application. Not only that, but the larger APKs get, the larger applications get, the more problems they may have installing for whatever reason, bandwidth, running into storage problems, whatever it is, right? So there's really a goal of having as small a distribution element as possible to get a better install experience and to be retained on the user devices. Meanwhile, the smaller download you have, the more installs you get. Again, data we got, which kind of makes sense if you think about it. So here's a little visual. The original approach with APKs is you have this monolithic APK, easiest way to manage it, just load everything up to the Play Store, and then everybody gets everything, right? Whether they need it or not. Whereas the dynamic delivery model of app bundles that you see on the right just picks the pieces that the user needs, right? They don't need all that language support. They only need the language support for their locale on their device. So we can leave all the rest of that stuff up in the app bundle. And instead, it just creates this customized APK that is much smaller that it can send down to the device. Another way to visualize it here, we have the app bundle that we upload to the store, and then it sends out basically different subsetted versions of it to each of the device. We also integrate this with dynamic feature delivery, where you can have different modules with different capabilities. Again, we don't download them all to all devices. Instead, we make the decision at runtime what needs to be downloaded to the devices. Much more efficient. So for app bundles, we've found great adoption so far. Over 500K of these things already out there. 35% of active installs are coming from app bundles already. And almost 50% of the top apps and games are using them already. You can get a size savings of, on average, 20% just from the automatic stuff that we're doing for you by not downloading everything. All right, so we're basically done. I want to walk through this really quickly. These are the pillars that I walked through. We've got language, which is Kotlin. We've got tools. Obviously, Android Studio APIs are essentially architecture components, constraint layout, motion layout, camera X, and material design components. Distribution, please go check out the Android app bundle. And please go check out the landing page. Modern Android Development has more information about all of these pieces. And I want to say thanks for listening and watching, especially to that phone message. That was cool.
Thank you. Thank you, Chet. That was quite an amazing presentation, including that special part with something seems to be falling into the screen. I expected to appear some very enormous thing like a Boston Dynamics robot appearing on the screen and fighting against you, something like that. But nothing happens, unfortunately.
Next time.
Dennis, you wanted to ask a question from you or from our
we
chat.
got several questions for you. So let's start with engaging our iOS developers, because it's mobile conference, not just Android conference, and maybe it's some managers also on the call. So 6 years before I was born, you got your first internship. Then Sun, Adobe, animations and UI. You did a lot in Google. I remember when I started Android, I've learned from your lessons on YouTube, and it was such a pleasure to see that. Then you tried to be dev advocate. Seems you not like that much, so you decided to be chief dev advocate. What are you doing right now on a day-by-day basis?
Well, a mix of things. For most of my time at Google, I was actually on the engineering team, and then I was leading the UI team until about a year ago, and then I moved over to dev advocacy, which is a mix of things. It goes anywhere from writing applications to understand how the technology works and how to explain it to people, to the main job is really essentially that. It's explaining to developers how stuff works, helping answer questions, because it's great to have a powerful platform, but if nobody can use it or nobody does use it, then what have you achieved? And so the developer relations team works on understanding all of the stuff that the platform team and the Jetpack team and all of these teams are writing, so that we can then go out to the community and write articles, do videos, do conferences like this, and basically have conversations that helps developers write better Android applications.
That's a question from our chat. The question is quite complicated, and please prepare to answer it honestly. So, where is the modern Android development talk name? Modern Android development, the names like Flutter or Fuchsia? Very complicated question.
They have nothing to do with each other. I can't speak to those projects. That's unrelated to Android development.
Okay.
I'm talking about Android platform development, the Android SDK, and modern Android development is about that.
Okay.
Yep. So let's talk about the development process. Every year you're presenting the most exciting stuff for us, Android developers. And what drives you most? You presenting new tools at the I/O stages, or at I/O YouTube streams, or the posting new jokes on Twitter?
Is my employer listening right now? I like all of it. I like posting jokes when I think of them. You can think of Twitter as my memory. Like if I think of something that I think is funny, I will post it, because otherwise I will forget. So it's really my notebook where I post funny things. But I also really enjoy doing talks and videos, right? I love the process of learning how something works, something, usually highly technical, like sort of getting my head around that, and then trying to figure out how to explain that either in article form or in video form or live in a conference presentation or whatever. So it's all good. I do enjoy sort of the interaction with the community. I wish this was a bit more interactive, frankly, but I do enjoy talking to developers about how stuff works. And if I can make it funny at the same time, then bonus.
Yeah, that's amazing. So while you present new stuff, but how the team deciding, and the different teams at Google deciding what's the most important to build in the next upcoming year for Android? Can you give our listeners some insights about the decision process?
Sure. There's a combination of things. It occurs to me, I think we asked the same question of Dave Burke when we had him on the ADB podcast about a year or two ago. So you could look for the Dave Burke podcast, whatever that was called. Dave Burke is the VP running Android platform engineering. So it's always interesting to see what their take on this is as well. It's a combination of things. One is we have more and more experience with the platform and have some idea. I mean, there's domain experts working in the various areas of the platform. So, for example, in the system UI team, they think about that sort of first front level UI experience of users as they encounter these phones and how they're interacting with the platform through that system UI and what they could do better. And so in this release, they came out with the people and the conversations capabilities based on their experience, as well as some user testing about the fact that people deal with people. Like, some of the most important things that you do on these mobile devices is to deal with the people in your life. And so they wanted to propagate that information in the UI in a way that made it much easier, right? So if you're in the middle of a conversation, then you go over and you check email, and then you get a notification that there's a conversation again, you want to make sure that it's really easy for them to get that information and to go back to that conversation as quickly as possible without having to navigate, back to home and back in the app and then down. And so that's based on a combination of experience as well as research and talking to users about how they use their devices. There's also some capabilities that come online in the ecosystem. One of the great things about the Android ecosystem and Android as a platform overall is that it's not all driven by us, right? We have so many other companies and people that are participating in the development of this thing. So if a hardware manufacturer has a bright idea to try out this new capability, and now they have, I don't know, a new authentication mechanism or a new camera capability or something, and it turns out that was a really good idea, then we have the ability to work with them to then integrate that in as a feature of the platform. I should point out, like, we don't put things in that are specific to manufacturers. It's more that there are hardware trends. Right. So we don't have something that's like, well, I sure hope I'm, running on a Samsung device because that's the only place this is active. No. It's more like that may have been a bright idea that was then adopted by other hardware manufacturers. Then we work with the ecosystem to make sure that that is a feature that is broadly available. So I think the hardware trends drive some of the capabilities and features as well. And then there are other things that come, frankly, from developers, where we discover architecture components is a brilliant example of this, where it was clear after talking to developers for years and years that Android lifecycle complications were not getting easier, right? Like, we can show that diagram as much as we want, but we're never going to make it simple to understand, or more importantly, to implement in the right way. And so then we took a step back and said, okay, how could we take a run at life cycles to try to simplify it for developers? How can we make our developers' lives easier? I think this is a really huge focus in the last few, I was going to say releases, but a lot of these capabilities are in unbundled libraries like architecture components and Jetpack in general, where over the last few years, we basically said, okay, what are the pain points? What is difficult about writing Android applications, and how can we solve those things one by one? We can't make it necessarily easy because mobile applications do a lot of things, right? If you want to access data on the back end and a database here and user interactions and performance, like, there's a lot of things going in there that can make it inherently complicated, but we can simplify the things that are unnecessarily complicated. And so that's been a big focus for us.
Time is running out, and we have time for at least 2 questions more. And one of the questions I would like to ask you, it's, as usual, it's a little bit complicated. Back into 19th, Java language, one of the main features of that language was interoperability. So you, as a C++ developer, could afford not to spend too much time getting into Java. So now, do you see any similarities across being a Kotlin developer after Java? And if you see so, do you think that the Kotlin will evolve in a more and more static manner, like Java? So literally, I can find the API which were introduced by Mark Reinhold 20 plus years ago, and it's still in Java. It's deprecated, but it's still there. What do you think about the Kotlin?
So, a couple of things. One is, actually, there were about 7 questions that I heard in there. Interoperability. I know that a lot of developers are starting to use Kotlin, not just on Android. I mean, clearly, when we adopted an official language for Android, a lot more developers came to Kotlin. But there are people that are doing things in the back end on server-side Kotlin and like it just because it's a good language. So we do think that these skills translate to other platforms. And there's something called Kotlin Native and Kotlin JS. So there's all kinds of ways that you can apply your Kotlin skills or learn your Kotlin skills elsewhere and not just on Android. I'm trying to remember the rest of your question. So yeah, I mean, Kotlin, any language has the raw, the fundamental constraint that we have on the APIs as well, which is we can't remove stuff, right? You're not going to remove, let's say, the fun keyword from Kotlin. Let's say they don't think it's fun anymore and they want to call it something else. They can't do that because they'll break things, right? That would be silly. So instead, it's an additive model. And so as languages get more mature, maybe things evolve more slowly. I think a couple of things are in Kotlin's advantages right now. One is that it's a relatively new language, and so there's still a lot of green field, a lot of open areas where they can go. Both, across other platforms is where a lot of development is going right now, but also in the core language itself, like coroutines, right? So they have the ability to keep building on in a more aggressive manner than some older languages do, because either they're constrained in all the things that they need to support at the time, or it's harder to add new features that don't quite agree with things that are there at the time. So there's certainly a lot more capability at this point in its life cycle, but also some of the fundamental characteristics of the language itself, I think, lend itself to evolution in a really great way. In particular, extension functions. So a lot of the things that you think of as capabilities of the language, they're not actually the language. I think, if I'm not mistaken, operator overloading is one of those where it's actually using extension function capabilities. Some of lazy, I think lazy is as well. There are some things where it looks like a keyword. It looks like you're actually executing language semantics, but it's not. It's just the way that you write it, and actually it's bottoming out in an extension function. They can add capabilities to what we consider as the language just by adding it to the runtime instead. And I think this gives them a lot more capabilities because they don't have to change the keywords. They don't have to change the fundamentals of how the language works in order to add all of these powerful new capabilities. The flow capability that they created for adding the ability to stream, use asynchronous and then stream the results, that's actually, that's not a keyword itself. That is a library. Right. So I think there's a lot more flexibility to language evolution in Kotlin than there are with some of the other languages out there.
Time's up, and this is the last thing I would like to tell you. As you might probably know, that the Kotlin, or the name of the language, has an origin from St. Petersburg. So next time I hope to see you in person here on the Kotlin Island. So you're gonna stay physically on the Kotlin with your bare foot, and you're gonna tweet it, obviously. So thank you, Chet, for joining us tonight. Thank you, Dennis, for helping us to make this very interactive. And I hope that you have everything in your background still standing still. Nothing has broken there. And this is the first. Thank you guys for joining us. And it's time to switch over to the next activity.
And we go into the discussion. Yeah. Thank you.
See you. Cheers. Cheers.